a tiny grain of sugar. It may look simple, but to create it, an entire gigantic system has to come alive. From the sun-scorched sugarcane fields to the roaring machines inside the sugar mills, then through countless steps of refining, pressing, drying, and packaging, all of these come together to create the sweetness that we so casually drop into a glass of water or hurriedly sprinkle over a cake each day. Few people realize that in the United States, the sugarcane industry is not just agriculture, it is the foundation of an entire economic system. Millions of tons of sugarcane, which is about 2.2 billion pounds, are harvested every year. Thousands of workers labor tirelessly, joined by some of the most advanced technologies, all to produce those neat little packets of pure white sugar that line the supermarket shelves. Behind that sweetness lies sweat, absolute precision, and a whole chain of strict processes. Every single grain of sugar is the result of the intersection between nature, knowledge, and human effort. And if you think sugar is nothing more than just sweet, then get ready, because the journey ahead will show you this: that sweetness is exchanged for an enormous system, where every detail carries an astonishing story. The lush green sugarcane fields stretching all the way to the horizon begin to transform when harvest season arrives. Gone are the days of groups of farmers bending over with machetes, cutting down each stalk one by one, as is still common in many other countries. In the United States, harvesting has been almost completely mechanized, turning fields that cover dozens or even hundreds of hectares, which is about 25 to 250 acres, into a bustling showcase of modern technology. Massive specialized harvesters, as tall as a two-story house, begin to roll across the rows of sugarcane. Their tracks grip the soil firmly, engines roar, and sharp front blades slice swiftly and cleanly through the sturdy stalks. In just seconds, sugarcane plants that stand nearly 2 meters tall, which is about 6.5 feet, are neatly cut down. The leaves are stripped away, and the clean stalks are carried into the storage compartment of the machine. The entire process, from cutting to leaf removal to collecting, happens in one smooth, continuous, and precise cycle. Behind them, a rotating conveyor system transfers the cleaned stalks onto large trailers moving in sync with the harvesters. What once required hundreds of laborers working for many days can now be accomplished in a short period of time with just a handful of these machines operating together. The advantage is not only in efficiency. Sugarcane begins to lose its sugar content very quickly after being cut. If left too long in the field, the sugar level drops significantly. That is why the entire harvesting process is carefully planned to minimize the time between cutting and transporting to the mill. Each stalk, once removed from the field, takes only a few hours to reach the crushing line, ensuring the preservation of its natural sweetness. Across the vast fields, the scene looks like a giant mechanized army. Harvesters in front, heavy trucks following close behind, and technicians standing on the vehicles, constantly monitoring the steady flow of sugarcane. Each machine can replace the labor of hundreds of workers, saving manpower while also ensuring consistency and quality in the harvested cane. From above, row after row of cane is cut neatly, leaving behind long, striped patches of empty ground. At the edge of the fields, trucks fully loaded with cane move out quickly, heading straight to the processing plants. The speed, precision, and coordination in every step make the entire harvesting process feel less like traditional farming and more like an industrial production line unfolding right in the middle of the countryside. Once collected, the sugarcane does not go through sun-drying or any manual handling in the fields. Every step is streamlined to preserve its natural quality. Modern technology not only changes the way Americans harvest sugarcane, but also directly determines the final quality of every single grain of sugar that reaches consumers. As soon as the fully loaded trucks of sugarcane arrive at the receiving area, the entire production line begins to operate. The cane is unloaded onto large inclined conveyor belts, where the long and bulky stalks are spread out evenly to move smoothly into the processing system. This marks the very first step of the closed-loop process inside the factory. The first stage is cleaning. While moving along the conveyor, the cane passes through a system of high-pressure water sprays arranged densely in multiple directions. Hundreds of strong water jets shoot from above, both sides and below, washing away the soil, sand, and mud clinging to the stalks from the fields. The water sprays are not applied just once, but go through multiple layers, from coarse rinsing to fine spraying, almost like a giant bath, ensuring that every stalk leaving this section is completely clean and free of visible dirt. The washing system is designed as a closed cycle. All the used water is collected in filtration tanks. There, layers of mechanical and biological filters remove impurities before the water is recirculated. This allows the factory to conserve resources while maintaining strict hygiene for the raw material. Cleaning is not only important for the quality of the sugar, but also prevents soil and grit from wearing down cutting blades or disrupting the pressing machines in the next stage. Once washed, the cane moves on to the chopping stage. Here, large cutting rollers spin at high speed, with sharp steel blades slicing the stalks that are 2 to 3 meters long, which is about 6.5 to 10 feet, into short segments only about 20 to 30 centimeters long, which is roughly 8 to 12 inches. This uniform size is essential because it helps the material flow steadily along the conveyors and into the shredders without clogging or jamming. Each blade is made from wear-resistant steel alloy, capable of working for many hours without becoming dull. To ensure both safety and efficiency, the cutters are placed inside enclosed chambers with sensors monitoring their speed, as well as cooling systems that prevent overheating from friction. With every stroke of the blades, dozens of stalks are chopped at once, creating a distinctive booming sound that echoes throughout the production area. Next, the short cane segments are transferred into the shredding system. This is the step that determines how efficient the pressing will be later on. Multiple rotating shafts, arranged in a staggered pattern, form a wall of blades that continuously tears the tough stalks into fibers and fine fragments. To ensure consistency, the shredding is usually divided into several stages. The first stage rips the cane into coarse fibers, while the next stages break it down further into finer, fluffier strands. The smaller the cane is shredded, the greater the surface area becomes, allowing the pressing rollers to extract the maximum amount of juice. If this step is skipped or done carelessly, pressing efficiency drops significantly, reducing the sugar yield and causing major waste. That is why the shredding blades are constantly adjusted to maintain the right speed and uniform particle size. During shredding, large suction fans positioned above capture cane dust and flying fragments, preventing them from spreading into the environment. These small byproducts are not discarded but collected and either fed into the boilers or mixed with the leftover bagasse after pressing to be used as biofuel. In this way, the production process not only maximizes efficiency but also makes full use of every part of the cane. All stages, from washing, chopping to shredding, are automated and monitored by sensor systems. Operators only need to observe the control screens, checking water pressure, blade speed, and the volume of cane being processed. If any problem occurs, such as a blade jamming or the cane being too moist, the system will trigger an alarm and automatically shut down to prevent damage. By the time it leaves this section, the cane has been completely transformed. From long stalks covered in soil and grit, it has now become a clean, fluffy, and uniform mixture of fibers. This is the ideal state for feeding into the pressing machines, where the juice will be extracted with maximum efficiency. After being washed and shredded into soft fibers, the sugarcane is fed directly into the pressing section. Here, enormous steel rollers come to life. Each pair of rollers has a large diameter made of hardened alloy steel with rough surfaces to increase friction. As the rollers rotate in opposite directions, the entire mass of cane fibers is pulled inside and subjected to immense pressure. Immediately, pale yellow streams of cane juice begin to flow out, dripping down into collection troughs below. From there, the juice is transferred to storage tanks, waiting for further processing. Meanwhile, the fibrous residue, known as bagasse, is carried away through a separate channel. Thanks to this separation, the raw material is divided into two streams, liquid for sugar production and solid matter for reuse. Typically, to maximize sugar extraction, pressing does not happen just once. The cane passes through multiple sets of rollers in sequence, each with different sizes and increasing pressure. The first pressing extracts most of the juice, then the remaining bagasse moves on to the second, then the third set of rollers. With each stage, the pressure becomes stronger, squeezing out the last drops of juice. Through this multi-stage process, juice recovery efficiency can reach over 90%. One important technique is that during pressing, hot water or a light solution is often added to the bagasse. This is called imbibition. The water dissolves the sugar that remains trapped in the fibers, and the entire mass is pressed again. In this way, more sugar is extracted, minimizing loss. At the same time, bagasse itself is far from wasted. A large portion goes directly into the factory's boilers, where it is burned as fuel to generate steam and electricity for the production line itself. Using this byproduct reduces energy costs significantly and lowers dependence on outside fuel sources. The leftover bagasse can also be dried and compressed into fiberboards for use in paper manufacturing, plywood, or lightweight construction materials. In addition, some factories repurpose bagasse for agriculture. After treatment, it can be turned into organic fertilizer or used as a growing medium. This approach not only maximizes the use of resources, but also helps reduce environmental waste. To ensure quality, the entire pressing system is carefully monitored with sensors that measure pressure and flow. If the pressing speed is too fast, the bagasse may still be wet, causing sugar losses. If too slow, productivity drops. That is why operators constantly adjust settings to balance efficiency with equipment safety. The rollers also require regular maintenance, with surfaces kept clean to prevent slipping or uneven wear. At the end of the process, The bagasse is carried out on long conveyor belts, stacked into large piles, or sent directly to the reuse section. The cane juice, the main result of this stage, moves forward into the settling and refining steps. Thanks to the multi-stage pressing system, every bit of potential from the sugarcane is fully utilized, providing an abundant flow of juice for sugar production while minimizing waste of raw material. Right after leaving the pressing system, the raw cane juice is directed straight into the treatment area. At this stage, although it has been separated from the stalks, the juice still contains many impurities: air bubbles, fine sand, tiny fibers, and organic matter that mixed in during pressing. If not removed, these impurities would directly affect the quality and color of the finished sugar. The first step is mechanical screening. The juice passes through multi-layered mesh filters with gradually smaller openings, which trap most of the fibers and coarse particles. The liquid then flows into settling tanks, where the principle of gravity is applied. Heavier particles slowly sink to the bottom, while the clearer juice rises to the top. To improve efficiency, certain safe chemicals are added. Commonly, lime or other clarifying agents are introduced in tightly controlled amounts. These substances help neutralize acidity and combine with impurities to form larger clumps, which settle more easily. This treatment step is widely used and standardized to ensure food safety and to guarantee the quality of the raw juice for the following processes. During this stage, a thick layer of foam often forms on the surface of the tanks. Automatic skimmers continuously remove this foam to keep it from disrupting the flow. Meanwhile, the sediment and mud collected at the bottom are gathered, then either treated or reused as agricultural byproducts. After circulating for several hours through filtration, settling, and chemical treatment, the cane juice becomes clearer, takes on its characteristic pale yellow color, and is almost entirely free of solid impurities. This is the clean sugarcane juice solution, fully prepared for the next step: concentration and further refining. After passing through filtration and preliminary refining, the clean sugarcane juice is transferred into massive industrial boiling pans. This is where a crucial process begins: concentrating the cane juice. Inside the factory, huge stainless steel pans operate continuously, connected together in a multi-stage system. The juice is pumped in and then exposed to high heat so that the excess water gradually evaporates. Every minute, white plumes of steam rise, while the liquid changes from a thin, clear solution into a thick, viscous mixture with a distinctive golden brown color. This is not a simple act of boiling. Both temperature and pressure must be carefully controlled by an automated system, with technicians constantly monitoring. If the temperature is too high, the solution risks scorching, altering its flavor and lowering its quality. On the other hand, if the heat is insufficient, not enough water evaporates, the liquid fails to reach the required thickness, and the sugar crystals formed later will be irregular. In many factories, to save energy and reduce nutrient breakdown, a multi-effect vacuum evaporation system is used. Here, the cane juice passes through successive pans at progressively lower pressures. This allows evaporation to occur at lower temperatures than normal, shortening processing time while preserving the purity of the liquid. As the juice thickens, its viscosity increases, and its color changes noticeably. From pale yellow at first, it gradually shifts to a warm golden brown, producing a light aroma that signals readiness for the next stage, sugar crystallization. This step is critical because if the concentration is not achieved properly, the sugar crystals later may form unevenly, vary in size, or even deform, leading to poor quality sugar. To ensure consistency, samples from each batch are tested after concentration. Indicators such as viscosity, color, and solid content are analyzed immediately in the factory's laboratory. Only when these values meet the standard is the thickened juice allowed to move forward to the crystallization stage. It can be said that this stage of boiling and concentration is the defining boundary in the entire production process. From what began as simple cane juice, it has now been transformed into a dense syrup, carrying within it the potential to form perfect sugar crystals in the step that follows. When the cane juice has reached the required level of concentration, the next stage begins. Crystallization, the decisive step in forming raw sugar crystals. The thickened syrup is transferred into specialized crystallization tanks. Here, the temperature is gradually lowered under strict control. The changes in both temperature and concentration create the perfect environment for sugar crystals to begin forming. At first, the process produces only tiny microcrystals, so small that they are barely visible to the naked eye. However, thanks to continuous stirring, these initial crystals slowly grow, expand, and connect into stable crystal structures. Constant mixing not only ensures even crystal development, but also prevents sedimentation or clumping, making sure the final sugar crystals remain separate and uniform. The crystallization period can last for many hours, depending on the syrup's density and the standards of each factory. Once complete, the entire mixture transforms into dark brown sugar crystals immersed in thick molasses. This is raw sugar. At this stage, raw sugar still retains its natural brown color and has not yet undergone refining. It contains a small amount of molasses, which gives it its distinct brown hue and rich flavor. This type of sugar is usually used as an intermediate material, sent on for further refining into pure white sugar, or left in its natural form for certain specialized food industries. This is a milestone moment. From a concentrated syrup, the very first sugar crystals have appeared. A rough, unrefined product, yet the foundation of the sugar we use every day. To obtain the pure white sugar crystals we use every day, raw sugar after crystallization must still go through a thorough refining process. First, the raw sugar is dissolved in hot water, forming a light brown liquid. This solution still contains impurities and molasses, so it undergoes several filtration stages. One common method is the use of activated carbon or specialized filtration systems, which capture natural colorants, remove unwanted components, and make the solution clearer. Once the impurities are removed, the clean sugar solution is boiled and concentrated again. Under carefully controlled temperatures, the water gradually evaporates, allowing the sugar to crystallize once more. This time, instead of the dark brown crystals produced earlier, the new crystals form as bright white, uniform, and consistent in shape. Finally, after being separated from the remaining molasses, the product is pure, dry, and free-flowing white sugar crystals. The very same granulated sugar we commonly use in cooking, baking, or simply stirring into a morning cup of tea. This refining process not only removes color and impurities, but also ensures safety and quality, transforming raw sugar into a finished product ready to meet the daily needs of millions of consumers. Once the refining process is complete, the dry white sugar crystals are transferred to the packaging line. Here, industrial dryers ensure that the crystals reach a stable level of dryness, preventing moisture and mold during storage. Next, the sugar is divided into two main types of packaging. For large-scale use in food and beverage manufacturing, it is packed into industrial sacks weighing from dozens to hundreds of kilograms. At the same time, part of the production is packaged into smaller bags of a few hundred grams or 1 kilogram, making it convenient for daily household use. Before leaving the production line, every package undergoes strict quality control, from purity and moisture levels to the uniformity of the sugar crystals. Only when these standards are met are the packages sealed, labeled with full information, and prepared for distribution. From there, the sugar is delivered to supermarkets, retail stores, and exported to international markets, completing its journey from the sugarcane fields to the dining tables of millions of families around the world. From the endless green sugarcane fields to the sparkling white crystals in your kitchen, we have followed a long journey where labor, technology, and knowledge come together. Every spoonful of sugar you stir into your morning coffee or sprinkle over a pastry carries within it a story of sweat, effort, and the creativity of countless people working behind the scenes. Sugar not only brings sweetness to our meals, but also reminds us of the connection between farmers, engineers, and a global industry. And perhaps the next time you taste a grain of sugar, remember that it is not just sweetness, but the crystallization of a journey worth cherishing. If you found this video meaningful, support us by following the channel, sharing it with friends, and leaving your thoughts below. In the upcoming episodes, we'll continue to bring you new journeys, where every familiar product carries surprising and fascinating stories.